Good morning, guys. Today I'm going to look at elasticity of substitution and production function. So, for production function, the elasticity of substitution between input I and j at point x is always defined as this. So this is the formula for computing elasticity of substitution. So suppose you are given a production function which is y is equals to x1 5 plus x2 5 like this, and you are asked to compute elasticity of substitution. So first of all, you specify your formula or ID, which is equals to differentiate len xj over xi over differentiate len fi over fj. So the x represent the input that we are using, and the fi is a partial differential of the production function. So let's say if I'm looking for the first part, then differentiate xj xi. Let's say we are using input 1 and input 2, then that means differentiate x2 over xi x1, great. Okay, so according to the law of logarithms, len x2 over x1 is same as what? Differentiate len x2 over x1 is equals to differentiate len x2 minus differentiate len x1. Okay, so this is according to the law of logs, right? And if I'm differentiating len x2, the same as you differentiate this and you divide by the same thing. So I'm going to use the total differentials to differentiate it. So I'll have differentiate len x2 same as 1 over x2 differentiate x2 is okay, minus differentiate len 1 x1. So when I differentiate x1, it gives me 1 all over x1 multiplied by the x1, right? So this represents the top part. So I can say differentiate len x2 over x1 is equals to 1 over x2 differentiate x2 minus 1 over x1 differentiate x1. So the second part is what? Differentiate len f1 over f2 is okay. So the f1 of f2 represent the partial differentials, right? So the production function is y is equals to x1 5 plus x2 5 1 over 5, right? So in this case, f1 is a partial differential, that is to differentiate y respect to x1. Okay, y respect to x1, and that is going to give you 1 over 5 x1 5 plus x2 5 1 over 5 minus 1 multiplied by 5 x1 5 minus 1. Okay, then f function to this must differentiate y respect to x2, and that is also going to give you 1 over 5 x1 5 plus x2 5 1 over 5 minus 1 x2 5 minus 1. Okay, so these are the partial differentials. So this expression is also the marginal productivity of what x1, and then this one is also yes, and this one is also the marginal productivity of what input 1, and this one is also the marginal productivity of what input 2. So the next one is to divide. So when we divide, f1 over f2 is going to give you 1 over x1 plus x2 phi 1 over phi minus 1 multiplied by phi x1 phi minus 1 over 1 over phi into bracket x1 phi plus x2 phi 1 over phi minus 1 x2 phi minus 1. So this cancels this one. This cancels this. So you have f1 over f2 to be equals to x1 phi minus 1 x2 phi minus 1. Great. So by the expression is what differentiate ln f1 over f2. That means I'm going to have differentiate ln x1 phi minus 1 over x2 phi minus 1. Great. So this one is the same as what? Differentiate ln x1 phi minus 1 x2 phi minus 1 is equals to differentiate ln x1 phi minus 1 minus differentiate ln x2 phi minus 1. Okay, so I can bring the exponents, right? So I'll have phi minus 1 differentiate ln x1 minus phi minus 1 differentiate ln x2. So when I differentiate ln x1, that is going to give me what? Phi minus 1 1 over x1 dx1. I'm using the total differential minus phi minus 1 1 over x2 dx2. Great. So let me factor out because the common term is this one and this. So when I factor out, I'll have phi minus 1 into bracket 1 over x1 dx1 minus 1 over x2 dx2. Great. So then let me do the total differential, right? So when I'm going to do the total differential, I'm going to have 1, 2 is equals to differentiate ln x2 over x1 differentiate ln f1 over f2. And we have ln x1 over, when we differentiated ln x2 over x1, what did we get? We had it as 1 over x2 dx2 minus 1 over x1 dx1. And when we differentiated ln f1, f2, what did we get? Okay, so we had it as p minus 1. Yeah. Dx1 1 over x1 dx1 minus 1 over x2 dx2. Great. So this is what we had. So when you look at this, then I can also say that this is the same as minus 1 over x1 dx1 minus 1 over x2 dx2 over phi minus 1 into bracket 1 over x1 dx1 minus 1 over x2 dx2. Great. So this expression here, cancel this. Then I have my elasticity of 1, 2 to be equals to minus 1 over 5 minus 1 will be the same as 1 over 1 minus 5. So this expression here represents the elasticity of substitution, right? Thank you.